Hello everyone. In this video, we will learn about SCR triggering methods. So let us understand what is triggering. So in short, we can say the turning on process of an SCR can be termed as the triggering. And in some detail, in technical way, when a SCR is transited from forward blocking state to the forward conduction state is known as triggering. Now let us understand what is the forward blocking state and what is the forward conduction state for the SCR. Let us consider the VI characteristics. This is the anode voltage and this is anode current. Now when thyristor is forward biased, the operating region will be this one. Now when we increase the voltage, the characteristics will go like this. Now if we observe that with increasing values of voltage, there is no increase in anode current. There is very small current in this region, which is basically the leakage current. So these characteristics where increasing voltage does not result in increasing current can be said as the forward blocking mode of the SCR. Here SCR is forward biased but still is not in conduction state. That's why this region is called as forward blocking region or the forward blocking state of the SCR. Now when voltage is further increased, the characteristics will shift from blocking state to conduction state. Here the voltage across the device will suddenly drop down and the current will start increasing abruptly with a minute variation in the voltage, or we can say with a minute increase in the voltage. So this region can be said as forward conduction region, and ultimately the transition of SCR from this region to this region can be termed as the triggering of SCR. Now let us see the actual VI characteristics of the SCR. This is the VI characteristics of SCR. This is the voltage applied across anode and cathode, and this is the anode current. As I said earlier, till this region the SCR is in blocking state. After this region, when further voltage is increased, the SCR goes in the conduction state, the voltage suddenly drops down and the current goes on increasing. This region is called as forward blocking region and this region is called as forward conduction region. Now next let us learn about the various triggering methods of the SCR. So very first method and the basic method is the forward voltage triggering. Next one is the thermal or temperature triggering. Next one is the radiation or light triggering, which is basically used only in case of LASCR, which is light activated SCRs. And the fourth one is dV by dt triggering. Here dV by dt refers to the rate of change of voltage with respect to the time. Here dV by dt is not referred to the magnitude of voltage but the rate of change of voltage. And the last one is the gate triggering. Gate triggering is the most common of the all and the most efficient method of the all. Now let us begin with the forward voltage triggering. Now let's see what happens in case of forward voltage triggering. Now this is your SCR, this is the anode and this is the cathode. Now anode is made positive with respect to cathode. Now if we see, the p-type material is connected to positive terminal and that's why the junction J2 is in forward biased mode. Here cathode is connected to negative terminal, that is the n-type material is connected to negative terminal, and that's why junction J3 is also in forward biased mode. Now if we look at the junction J2, here this junction, N type material is connected to positive terminal and P type material is connected to negative terminal, and that's why the junction J3 is now, the junction J2 is in reverse biased mode. So according to this situation, there is no clear path for the conduction of current from the anode to the cathode because of the reverse biased mode of junction J2. That is, if we see the overall condition, the junction J1 is reverse biased, the junction J2 is the junction J1 is forward biased, junction J2 is reverse biased, and again junction J3 is forward biased. Now next method is thermal or temperature triggering. Here, according to the true transistor analogy of SCR, we have one equation, that is IA, which is anode current, is equal to alpha 2 Ig plus ICBO1 plus ICBO2 divided by 1 minus alpha 1 plus alpha 2. Now as we go on increasing the temperature, the factor alpha 1 plus alpha 2 goes on increasing, and the total term, the denominator term, goes to 0, and the anode current goes to high value. And if we try to learn that way in physical manner, if when we increase the temperature at the junction, the mobility of the charge carriers goes on increasing, and as the result, the depletion width of the junction J2 goes on slightly decreasing. So as the temperature increases, the depletion width of the junction J2 goes on decreasing, and as the result, when voltage VA applied across the anode and cathode of the SCR is near to the breakdown voltage, and we increase the junction temperature, by increasing the junction temperature, the reverse bias junction collapse, and thus the device starts to conduct. The next method of triggering of SCR is the radiation or light triggering. As I said earlier, this method is applicable in case of LESCRs, where LESCR are the light activated SCRs. So let us see. Here is one SCR, which is LESCR, and there is one window over here at the junction J2 where light can be incident. As we said earlier, the junction J1 is forward biased, the junction J2 is also forward biased, but the junction J2 is the reverse biased junction. So when light is incident on the junction J2, there will be some photons released in the depletion width of the junction J2. These extra charge carriers will try to flow from this junction to the next junction, and due to this mobility of charges, more charges will be generated, and hence the depletion width of the junction J2 goes on decreasing, and ultimately the junction J2 collapses, and there is a clear path from anode to cathode to flow the current, and hence again we can say the SCR has been triggered, or the SCR has been turned on. Now the next method is dV by dt triggering. People often get confused between the forward voltage triggering and dV by dt triggering. So let us learn about the concept of latching current. So latching current is the minimum value of current flowing through the SCR, that is anode current, beyond which SCR is completely turned on and remains in on state even on removal of gate signal. That is, when SCR is completely turned on, even if we remove the gate signal, the SCR will still remain in the on state. The latching current is basically associated with the turn on process of the SCR. So SCR will go into on state and will remain in the on state when the value of anode current IA will become more than IL, where IL is the latching current. Now let us see what is dV by dt triggering. Here the term dV by dt refers to the rate of change of voltage with respect to the time. Now we will learn what is the significance of the rate of change of voltage. Now the first condition here will be the when SCR is forward biased, the junction J1 and J3 will be forward biased and junction J2 is reverse biased. Now here the junction J2 behaves as a capacitor because of the accumulation of the charges on the top and bottom side of the junction J2. Now if we consider the voltage applied across the device is V and the charge is denoted by Q and the capacitance by C, then the equation of charging current is IC is equal to C multiplied by dV by dt. Here the IC, which is the current flowing through the SCR, or again we can say it is the anode current IA. Now when dV by dt is high enough such that the IC becomes more than IA, which is anode current, or we can say when IC becomes more than latching current, then device is completely turned on. Now the last one, the gate triggering method. Here again anode is made positive with respect to the cathode. Junction J1 is forward biased, junction J2 is reverse biased, and junction J2 is again at forward biased state. Now here at the junction J2 some current is injected, and because of that current some initial conduction area is started. That initial conduction area will allow some of the current to flow from anode to the cathode. Because of that small current, the conduction area will go on increasing, and again the value of current from anode to cathode will go on increasing. So the conduction area goes on continuously increasing, and ultimately as a result the value of anode current, which is denoted by IA, goes on continuously increasing. These two are cumulative processes and goes up till until the anode current reaches its full value. We can see here in the wave characteristics, when Ig is equal to 0, that is the gate current is 0, the breakover voltage required will be VBO, and if Ig is applied, let us see Ig1, and let us see the corresponding voltage will be VB1, and the corresponding voltage for Ig2 will be VB2. So as the values of gate current increases, the breakover voltages of the SCR goes on decreasing. In this way we have a better control over the timing of the turning on and off of the SCR by gate triggering method. This is the most widely used and the most efficient method for turning on of the SCR. So let us stop here. This was all about the triggering methods of the SCR.